Hello, everyone, and welcome to today's webinar, Terraform with Sentinel, How and Why We Built Policy Management for Cloud Provisioning. We have a very special webinar today with HashiCorp co-founders Mitchell Hashimoto and Armon Dadgar. Mitchell and Armon will walk through why they created Sentinel and go into an in-depth demo. They will then take a few questions from the audience. Please feel free to type your questions during the webinar. Mitchell and Armon will answer the questions during that final segment of our webinar. I also want to note that this webinar is recorded, and the recording will be made available after post-processing, usually within about 2 days. I'll email it out to all of you. With that, let's go ahead and get started. Take it away, Armon.
Cool. Thank you, Amanda. Let's see. Let's see. Is this showing the screen? Cool. Awesome. Awesome. Well, thank you, everybody, for joining us. I think this is a bit of a different format for us, so it's going to be fun to kind of go through this one, and I'm happy to have Mitchell with me. So just as a way of sort of brief intro, my name is Armon Dadgar. I'm one of the founders and CTO, and then joining me is also Mitchell, the other founder and other CTO. And today, the kind of topic we want to talk about, what we want to get to eventually is a little bit of, what was the kind of inspiration behind Sentinel and why do we think that's kind of the extension of infrastructure as code and what we've been trying to achieve with our other tools. But I think first we think it might be useful to set a little bit of groundwork and a little bit of context before we get there. So I think most people, just based on the kind of registration of the webinar, sound like they're familiar with Terraform or at least some of the HashiCorp tools. But just to give a little bit of context on kind of what HashiCorp does and how these different tools relate to each other, our ultimate focus is really about letting the practitioner be successful in kind of 4 different categories. One is provisioning of infrastructure. So largely this is where we focus on with Vagrant and Packer, and Terraform is really looking at how do we consume infrastructure and manipulate it and sort of do our day 1 provisioning and day 2 management and things like that. At one layer up from that is great, we're running this infrastructure, but we have all sorts of credentials we need to manage. We have endpoints that we need to protect. We have data that we want to encrypt. So we have a set of security challenges that largely security practitioners are looking at. And this is where our tool Vault helps those practitioners. A level above that is how do we focus on making the development experience easier and providing sort of higher level platform tooling for deploying applications, scaling up and down, rolling back, rolling forward, doing this sort of platform-oriented application orchestration, and that's our scheduler Nomad. And then the last component is how do we wire together all of our services? So in sort of a microservice environment or service-oriented architecture, how do these different components discover one another, get configured, do locking and leader election, and all the coordination our modern services need? And that's really where Consul comes in. So together, the kind of mission of the company is helping the practitioner, provision, secure, connect, and run, but doing it in sort of an agnostic way to what type of infrastructure is being run. And so, this may seem like a broad set of tools in sort of many different categories. And I think what was super important to me and Mitchell from the beginning is that it didn't feel like, a random hodgepodge of tools that are all trying to do a different thing. And so very, very early in the process, we published something we call the Tao of HashiCorp, and I think Mitchell's given a good talk about it, which is really meant to be the sort of unifying principles that make sure that all these tools all feel consistent and sort of solve the problems in a uniform way. And so, Mitchell, do you think you might be able to talk a little bit about sort of the Tao and how it affects the tools?
Yeah, sure. So, like Armand said, I've given sort of a talk on this. There's a 10-minute talk out there where I go in a lot more detail on all of these 4, so we could get to Sentinel and some of the other policy stuff. I just want to highlight a few that were important with regards to more Sentinel headed, and then also its sort of integration with Terraform. So the first one that's super important is just the idea of codification in general. So this would be versioning through codification and automation through codification. And this is really, to be brief, is an idea that knowledge should be taken, out of our minds and codified into a textual format. And because it's in text, we could version it. We could put it in version control. We could see a revision history. We could do sort of software engineering best practices on anything codified with pull request review and automated testing and analysis on top of it and things like that. So by taking knowledge and putting it into code, you automatically sort of start gaining capabilities that are simply impossible otherwise. So that's extremely important. The other thing that's important is workflows, is the idea that we have this generic problem, and in the case we'll talk about as policy, it's this idea of enforcing business rules onto various processes, and we want to do so sort of regardless of the underlying technology. And so trying to think through how do we integrate this into our existing workflows, but also build a workflow around that itself, so that whether you're using Terraform or Console or these other tools, like the idea of enforcing policy is a singular shared workflow. And the others come into it as well, but I think those are the three that are extremely important to highlight. And if you want to learn more about the Tau, I sort of recommend reading about it at hashicorp.com/Tau. It won't take you too long, and I think it's quite revealing on our views on what makes good infrastructure software. So with sort of those in place, I'll hand it back to Armon to sort of talk about how the Tau sort of came through into a solution we built for infrastructure as code, and sort of how that leads to Sentinel.
Awesome. Yeah, I mean, I think what's interesting is, the idea of codification and, applying it and getting the benefits of versioning and automation is in some sense not specific at all to infrastructure. In some sense, that is what an application already itself is, right? It's a codified version of an idea. And so, I think the notion of infrastructure as code was partly saying this was a really good idea in development land and a really good way of scaling up, how we sort of think about automating business process. But how do we bring that sort of the benefit of, this as code to the way operations is managed? And so I think that's really what's distinguishing of infrastructure as code as opposed to just, code as code, is it's really within the domain of how do I manage infrastructure? And so I think oftentimes people ask us and say, this sounds very abstract, right? Like, what are the concrete things that this really helps us with? Because clearly we've been able to manage infrastructure without this. So like, what's new? What's different? Why bother? And so I think what's helpful then is to kind of go through a set of challenges, right? I think, a very, very common one is, great, yes, we've manually been able to point and click or use other techniques to bring up our production environment. But now, what if I ask for a carbon copy of that environment for staging or for QA or for a personal dev environment, right? How long would it take me to go from my sort of handcrafted production environment to being able to stamp out one of those per developer? So that's sort of an example of it. The other question is just like, how long does it take to deploy a complex new application, right? Is this, a 5-minute effort? Is it a day effort? Is it a month-long effort, right? And I think that sort of rule stick or sort of guide stick tells us something about like, how good is this automation? How good is this process, right? If it takes us a month to deploy an application, maybe the way we're doing it today isn't the best way to be doing it. And so there's kind of the day one concern of just deploying it, and then the day two concern of, great, this thing is running in production. Do I understand it well enough to be able to safely update it? So if I want to just change a version or scale it up or down, what does that sort of entail? And then you get into some of the more sort of documentation oriented things, right? Which is, do I just understand what this infrastructure actually looks like? So I think once we start asking these questions of ourselves, I think this is where it becomes clear that for the most part, the kind of handcrafted or point and click approach for infrastructure doesn't work very well, right? It becomes really obvious that, yeah, if I wanted a second environment, I don't really actually fully know what my production environment looks like. So creating a carbon copy is almost impossible. And that the amount of work it takes to deploy a new application is, it's the same amount of work, and it's a lot of work every time. And so this is what ultimately led us to building Terraform, which really was the first for us in terms of saying, okay, how do we bring this kind of infrastructure as code approach to the realm of actually managing infrastructure. And so what Terraform does is pretty simple. It has its own DSL or domain-specific language that lets you specify, what should be running, right? So you don't specify, what to boot or what steps you should take. It's very declarative. You just say, I want, a private network. It should have 10 VMs in it. That should have a load balancer. And here's the relationship between them, right? The load balancer points to those 10 VMs. Those 10 VMs are running within a particular network. And so you just give all of this to Terraform. You just declare that this is what I want the state of the world to be. And then it's Terraform's problem to sort of make that happen, right? To sort of make the world in its image, if you will. And so the way it does this is really, it has kind of three distinct operations. One is sort of, a reconcile with the real world, which is like, okay, what's actually running? This is called refresh in Terraform's land. Then there's a planning phase where Terraform figures out, okay, you want 10 VMs to run, currently 5 VMs exist, so I need to boot 5 more. The plan is to launch 5 VMs. And then there's the apply phase where Terraform actually goes out to the world, talks to the cloud and boots the VMs. And so that hopefully when Terraform finishes running, the world does look like how you've asked it to look within its declarative config. So we won't go into a whole lot of, Terraform detail. I think there's a lot more sort of good material online if you're interested or new to Terraform. But I think that it's important to understand sort of the gist of what Terraform's trying to do, which is letting you specify sort of in a code-like way what your infrastructure should look like, and then applying sort of this workflow on top of it. And I think if we do that correctly, what we've seen is that we can kind of get the best benefits of all the things we've learned in software development land, right? So we can get versioning of the stuff because we can check it in to GitHub. We can get peer review, so we can do sort of a branch and have a peer do a review of it before merging it in. And then we get some of these other benefits, right? So we get abstraction and encapsulation. So I don't have to redefine how to deploy a complex app every time. I can sort of define that in a module, almost sort of like a library functionality, and then just pull it off the shelf every time I want to deploy that application. So I don't have to spend weeks or months on my new application. I can do it in minutes, right? So I get this code reuse, I get this abstraction, and this leads to a lot more ability to automate and have high leverage than sort of doing it in a handcrafted type of way. But I think this leads to an interesting challenge. And Mitchell, do you want to maybe give a quick primer on sort of like the paradox of automation and where this leads us?
Yeah, so we've, we're really strong believers in automation, and we built Terraform, which we believe is this incredibly powerful tool to automate what before could be a very frictionful process to build some really complex infrastructure. And we've also introduced a number of other automation tools in other spaces. And sort of the paradox that comes up is as you sort of break down these barriers, as you make this a frictionless and process and so easy, is that there's a lot of, risk of messing something up associated with that. There's a lot less checks along the way. And so I'm not controlling the screen, but Armon, can you go to the next slide? So one thing you start missing is this basic sanity checking. Automation, is not that intelligent in this regard. If in the previous world, what you would do is you would sort of ask procurement for something like 5,000 VMs, and this would be a non-automated, frictionful process, but procurement would probably respond with, are you sure that's the right number? Because that's quite a number of VMs that you're asking for. But today, if you take Terraform and you just change one little number from 500 and fat finger another 0, or you just typo something and you ask Terraform to spin up 5,000 VMs, then it's not going to ask you anything. It's just going to go and start trying to do it. And maybe something else will block you, like AWS won't let you spin up that much, or another cloud platform, or there's billing issues. But Terraform's going to try to spin up those VMs. And if you're in a business, it's likely to succeed. And so this is obviously not good and could be a very expensive mistake. In addition to just sort of expense and financial stuff, there's issues of security here. You could very easily and unexpectedly, sort of with the wrong keystroke, delete a very important sort of firewall rule. You could you could actually have sort of bad actors in the company that use a large pull request or a large code change to sort of hide malicious intent if they intended to. There's a lot of sort of interesting new challenges sort of that happen as part of automation. With all the benefits we get, we also lose these sort of roadblocks, and the whole point of automation is to get rid of roadblocks, so it's working as designed, but you still want to be able to prevent bad behavior, whether it's intentional or not. And so really sort of to get from there, you need policy. And so there's really only two options, right? There's sort of policy for by putting a human in the loop, by reintroducing roadblocks and reintroducing some friction and using friction as your point of policy. Or you could take the approach, more in line with our Tao, more in line with our view of the world, which is, can we codify what's trying to be done? Could we automate what's trying to be done and actually use automation to our advantage as part of this policy? But regardless, in every case, the answer is policy. And so there's these multiple types of policies that we introduce, and I guess from here I'll just hand it back off to Armon to talk about sort of how policy fits into the workflow and how that led to Sentinel. But hopefully that gives you some of the ideas of the challenges.
Yeah, and I think it might be useful. I think one sort of example we went through there is kind of just the, I fat finger and put in 5,000 VMs when I really meant 50. And I think that's sort of one type of it, right? I think that falls into this sort of accidental error type of thing. But I think it's worth talking about some of these other ones, right? Which is, and I think you touched on it, sort of compliance bypass, or if you have bad actors, right? And so I think in practice, what we see that translates to is sort of three different classes of policy in the wild, right? There's sort of, compliance policy. This is, almost entirely externally imposed, which is, hey, we have to be SOC compliant or PCI compliant or, GDPR compliant. And so there's some external agency that's saying, like, here's the checklist of things you must do. And so that's being translated to sort of an internal checklist of policy. Then I think there's sort of, and so sometimes compliance might be called, sort of like big S security, right? It's sort of security in quotes because it's like questionable how much security is actually gained, versus sort of little s security, which is like, oh no, we care about things like, which machines are exposed to the public internet and which ports are accessible, and should you be able to reach SSH, and are things properly locked down, right? Sort of like little s security. So I think there's a whole set of security policies that are maybe not externally imposed, that an internal security team might be like, yeah, only this traffic is allowed to be, accessible to the public internet. And then there's like the third class, which is that sort of operational excellence, right? Or operational best practice. I think that's where you would catch things like the, whoops, I typed in, 5,000, right? And I think that category ends up being the sort of way an organization learns from mistakes, right? And I think a classic, example of this will be, you deploy a service with the count is equal to 1, and that VM fails, and there's no redundancy, right? Because there's only one instance of it running, and so there's an outage, right? And so I think organizationally, a lot of organizations would respond to that by saying, okay, great, our standard is for any sort of maybe user-facing service, there has to be at least 2 instances running, so that if one fails, there's sort of an HA, right? And so this is this type of policy that an organization will impose on themselves to maintain this sort of operational best practice. And so what we tend to see in the wild in terms of how these policies actually get implemented is there's sort of a split, right? That you have your IT operators who are sort of doing their actual sort of day-to-day, I'm making a change, I'm deploying my service, things like that. And oftentimes they get pushed into a ticketing flow. So I want to deploy my new service, great. Here's the, maybe the Terraform I'm going to write that's going to do that. So I submit a ticket that says, please review this before I can hit apply. And then oftentimes that sits in a queue until a compliance or security team is able to look at it. And then they're sort of playing a 2-part role, right? They're both defining what these policies are in terms of compliance, security, best practice, right? Or at least they're maybe the curators of it. But they're also the verifier. So they're kind of going top to bottom on what's basically just a Word document and saying, check, 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 check. Did all these things get met? If so, great. You're allowed to do this thing and close the ticket. Otherwise, the ticket gets closed, it's like, sorry, you have to make these changes, you're out of policy, right? So this tends to be the typical workflow we see. And I think, Mitchell, you already hit on it, that this felt very wrong to us coming from sort of the Tau, right? Like the idea that an operator would have to file a ticket and just wait for someone to review it, to basically just read a Word document, didn't seem right. It didn't fit with the Tau of HashiCorp. And so I think, to Mitchell's point, there's really these two ways to do it, right? It's like you either are automating it or you're not, right? And so our view is, how do we automate this, right? How do we get this policy out of a Word document and out of a manual ticketing queue and into sort of an automated enforcement loop, right? And so, I think one of the things Mitchell started at the very beginning by talking about was saying, like, if we get things as code, right? If we're automating it, then what we get is the ability to reflect on it, right? We can have higher level code that can look at the other code and say, hey, is this valid? Is this, within the sort of bounds of what's acceptable? And so in some sense, that's what policy as code really becomes, right? It's this sort of meta code that's sort of governing the infrastructure as code. And what it's really trying to do is define a sandbox and say, great, if you've asked for anything less than 100 VMs, that's okay. So you can ask for 5, you can ask for 50, but you can't ask for 500, right? And so we define this sort of meta sandbox where you can write whatever Terraform you want inside of it up until you hit the boundaries, right? But if we do this correctly, then we can get rid of the ticketing queue, we can get rid of the sort of Word document and get those same Tau benefits of versioning and automation through codification. And so, our sort of, where the thought began was really more at the sort of principled concept of policy as code. And then ultimately that ended up getting turned into a project called Sentinel, which maybe, Mitchell, you want to give kind of an overview of.
Yeah, so we started approaching this problem, I think initially in Terraform, and sort of as we were approaching the problem, customers and users and almost all our other tools started coming out and saying it's a similar issue, slightly different shaped, but a similar issue in there as well. And so we started to just view sort of what can this be abstracted into a framework? Can this be like a common system among our tools? Because that would be a lot easier than learning sort of n different systems. And we're able to do that. So Sentinel is the name of the common sort of framework and tooling that we use across multiple tools. And we're going to talk specifically about Terraform here. So Sentinel is a framework. And so that what that means is that it is embedded sort of directly within the application. It's not something you run separately. It's not something you add on. It's just sort of built right in. As part of Sentinel, what you get is you get a language. So there's a language you write the policies in. You get the runtime, which is actually enforcing the policy. You get a simulator locally so that you can develop policies without having to like run the actual software. And then you get an SDK so that you could actually extend Sentinel to access information from other systems. And all these are really, really important. So I'll go sort of just a paragraph or so along each one. So the language itself. We've sort of been asked before, why did you sort of create a language? Why did you use a specialized language? Why didn't you use something else that was off the shelf? And sort of in doing so, actually for this one, Armon, could you just go to the next slide?
Sure.
So in doing so, in implementing Sentinel, we actually did use a number of different languages prior to starting to design our own. We were looking for a couple qualities that were sort of absolutely sort of we couldn't compromise on. One of them was that it had to be non-programmer friendly. The reason for this is that in a lot of organizations, the team and the people who are defining and verifying the policy aren't professional programmers. They might be somewhat familiar with coding, they might be familiar with certain DSLs, but they're not professional developers who are comfortable with sort of a lot of the abstract and common concepts among programming languages. So it had to be non-programmer friendly. It also had to be sort of easy to embed and secure at the same time, because these are things that will be sort of embedding in the data flow of infrastructure creation and secret access and vault and KV change in console and things like that. These are security sensitive contexts, and we wanted something that we could reason about easily and sort of control easily if we view any sort of security risk. And so in doing these sorts of things, we sort of tried a bunch of different languages and came up with our own, which is an open specification you could look at, and we encourage sort of alternate implementations as well. There's a couple other traits that we got out of it, which is really nice, which I'll touch on before we switch from this slide, is that it's relatively simple. I think this goes hands in hand with non-programmer friendly. The language can get deep, like if you're a professional programmer, loops and conditionals and all those sorts of things are there, functions are there if you needed them, but you generally don't right away. And so there's a simplicity aspect to getting started. It's debuggable, so we've exposed concepts such as rules and predicates sort of into the core of the language, and by exposing those as first-class things versus just expressions like any other language, is that we could actually we sort of keep track and use them in debugging data. So like when a policy fails, instead of just saying it failed and it failed maybe on this line, we actually could tell you it failed, and here's sort of the trace, not even of current ones, but historically executed sort of predicates and logic that led to this point. So you could see sort of the values of all the true false, and most policies break down to true false, ANDed and ORed together. And then can you go back one slide again, Armon?
Sure.
And so that's a language which is sort of a big thing, a big deal. The rest are quite a bit simpler. So there's an embedded runtime, like I said, it's just built in. The simulator is something that lets you sort of run Sentinel on your own computer. You could write policies, create mock environments. So pretend that somebody just requested 5,000 VMs and run this policy. Does it pass? Does it fail? And an important feature of the simulator is that it has a built-in test framework too. So you could actually codify and write automated tests so that you could actually specify the scenario that if someone were to ask for specifically 5,000, that it should fail. And if someone were to ask for 50, it should succeed. And you could create all these, for people that are familiar with programming, you could create all these scenarios and specifications that verify your policy, so that as the policy also evolves, you can imagine some automated tooling in the back that's verifying that past specifications are still satisfied. And then the last bit, which is really, really powerful, is the import SDK. So the import SDK allows Sentinel to access external information in making policy decisions. So you could imagine that you have some internal, let's say, inventory management system internally in your company, and you want to make sure that if someone is sort of making change to a system, that system is reflected in your inventory management system before that change could actually happen. And so with the import SDK, you could write your own plugin to Sentinel that works with all our software. You could write sort of libraries that it can access that internal system that we couldn't know about, we couldn't really do, and use that for policy decisions. And the most important quality you get out of this is flexibility with policy that really no other policy system will give you. And so that's sort of the whirlwind overview of Sentinel.
Yeah, and maybe I'll just add to the import one. I think sort of a question that we get relatively often that I think kind of goes to why we have this import idea is, what's the difference between sort of policy and an access control, right? So an ACL versus a policy. And I think the biggest difference is sort of, is it low context or is it high context, right? I think an ACL tends to be like, if a user is a member of this group, then allow the operation, right? It's pretty low context in terms of like what information is needed to make that yes or no decision, versus when we look at sort of a standard policy, it's way different. It'll be something like, if this is a staging environment, then you're allowed to have, only a single instance of a service. But if this is production and it's a user-facing service, or it's a data service, then you need redundancy. So there's all these ifs and or buts that are like, you need to know, is this staging? Is this production? Is this a data service, right? So there's all this richer context that is necessary to make a policy decision. And I think one of the reasons that this drove us towards the import SDK is no one system will typically have all this information. Like, it's not necessarily going to be obvious to Terraform that this is a user-facing service or not, right? And so I think this ability to import is sort of, it kind of lets you pull in context from the other systems that might have it. So whether it's, as Mitchell said, the inventory system, or maybe your monitoring system knows, hey, are we in the middle of a Sev 1? And we have a rule that prevents us from changing infrastructure in the middle of a Sev 1.
I think it's important to highlight, I saw this in the questions, but I think it's important to highlight that, yeah, Sentinel is a feature that's only part of our enterprise offering.
Yeah. So I think we've talked about it a lot. Maybe it might be helpful, Mitchell. Do you want to talk through a few examples of it?
Sure, yeah. So we have a couple examples on these slides, and I'm going to show you some examples that are real in a demo too. So this is just a basic example to show you just the language. It's not doing anything super realistic, but it's possible. So basically, you could see that there's this rule object. A rule is something that either is passed or fails. Like imagine a rule just in real life, like you're either adhering to the rule or you're not. And so that's what happens here. The rule is defined as sort of all items in some object need to match this regular expression. They need to match this name. And so this is abstract, but if you were to make this type of pattern concrete, you could imagine that every sort of instance or VM in your cluster has to have a name that matches some sort of syntax that some automated tooling you have uses, or that every sort of key coming into every tag key has to match some sort of syntax so that you don't collide with some other systems or something like that. So this is a really basic example. The next example is much more real, but also it's hard to fit sort of real things onto a slide with a large enough font. But basically what this is doing is this is a GCP policy. It's a policy that one of our customers actually uses and we have to share. This is a policy that says that for any Google GKE cluster, that the instances within the cluster must only be N1 standard 1 or N1 standard 2. So you could, if you read it bottom up, it's actually a little bit easier. At the bottom, you can see the rule is actually that the machine type is allowed. That reads a little bit nicely, like the rule is passed if it's an allowed machine type. So moving sort of up from there, machine type is allowed is itself a rule. And this rule sort of goes over all the clusters that we have and then all instances within that cluster and verifies that the machine type is in the set of allowed types. And then sort of going up from there, you can see that the set of allowed types is these two types. And so this reads, I think, pretty clearly and is a really, really common policy.
And I think here you already see sort of an import, right? So maybe just talk through kind of what the implication of that is in terms of sort of importing this external context.
Right. Yeah, that's a really great point. So when you run policies within Terraform, we wrote this import called tfplan and we expose it directly to you. And what this import does is actually allows you to access all the details of a Terraform plan. So you could look at the state previous to the plan. You could look at the configuration that was used to create the plan. You could look at the sort of simulated state after the plan, which is really, really powerful. You're basically asking, if this plan were to be applied, what would the state of world probably look like? And you can see that happening here. There's not line numbers, but the line sort of 2/3 of the way down that says r.applied.node config. That applied means that if this plan were to apply, would the machine type in the node config be in the allowed types? So you're not just testing that the configuration says this, you're also testing that Terraform itself is planning to do this, which is super powerful.
So I think another sort of interesting thing that comes with it is this notion, I think you said it, which is like a rule is, you're either passing the rule or you're failing the rule. But I think in the real world, things are a little more gray than that. Do you want to maybe explain enforcement levels?
Yes. So a really common thing that popped up is this idea that policies are very typically not, just pass fail. There's three actually common scenarios that we found in working with customers. So we worked with a sort of set of customers to design Sentinel prior to public release. And enforcement levels are one of the abstractions that we found that was common among them. So enforcement levels sort of dictate the behavior of a policy when it fails. And so there's three enforcement levels built into Sentinel. So every system sort of can have this. There's advisory, soft mandatory, and hard mandatory. Hard mandatory policies are what you would expect. They must pass no matter what. No, ifs or buts about it. If the policy fails, this behavior cannot happen. That is your very hard line policy. A soft mandatory policy is a policy that if the policy fails, that it'll block the behavior, but someone with sufficient privilege can override that failure. And so the idea of sufficient privilege is dependent on the software you're talking about. So in Terraform Enterprise, it's somebody else on your team. In something like Nomad, it's somebody that specifically has the override sort of privilege or ACL. There's various ways to look at it, but basically if this policy fails, you could go knock on someone's door, metaphorically or maybe literally, and ask them to override your policy. So a great practical example here is a policy that says you can't deploy to production on Friday. Deploying to production on Friday is a very, very common way to make someone's weekend poor. So if you're deploying on Friday, you probably want to make sure you know what you're doing. And so a soft policy is a great way to do this. The policy fails, you need n equals 2 individuals to come and really think about it and say, okay, yes, let's deploy it, override the policy. It also gives you a bit of repudiation, right? It gives you the idea that the person that initially initiated the change saw the policy fail and consciously decided to override or ask for override for that policy. So they knew the risk that they were getting into. There's no real excuse that says like, oh, I forgot about that. Like the system told you and it failed. And then the last policy type, enforcement level type, is advisory. And advisory policies can fail and the behavior is still allowed to happen. These are, I forgot the terminology Armon used, but these are policies that are more educational, operational excellence. I think it would be what it would sort of fall under. These are ways to educate users. These are ways to sort of warn about deprecations or change in policy coming without actually breaking existing practices. So a good example of an advisory policy is something like a new instance type is introduced and the organization is switching to that new instance type and they don't want to use the old one anymore. So you'd write a policy that disallows the use of the old instance type, but you don't want to just break all the automation instantly. So you set it as advisory. What this does is shows the user a warning that says this policy failed, but we're allowing it to go through. That sort of hints to the user that there's something wrong that they should probably address. And to give a concrete example here that we've talked about publicly before, Barclays is one of the customers we worked with in designing Sentinel, and their use case for advisory policies is enabling and educating much more junior people. It's teaching people that aren't as familiar with the cloud platforms that they use how to use them better. Like, if you, as Armon said, if you create, let's say a database and the database has a flag that automatically, as a service provider, automatically does HA across availability zones. If you didn't enable that flag, like use that as an education moment to teach that user, this flag exists, we prefer to use it. Are you sure you don't want to use it? Those sorts of things. And so these are built into, like I said, the Sentinel system separate from the policies. So you write the policies themselves. A policy itself could be advisory, soft or hard. And when you sort of import or configure that policy into your system, you then apply the level to it. And this is important because an advisory policy for one group of individuals may be a hard mandatory policy for another group of individuals who should know better, and things like that.
Right, or maybe it's staging and prod are a little bit different, right? Might be advisory and staging and mandatory and prod.
Right.
Cool. So I think, in some sense, coming all the way back then to the workflow, our goal, the very original goal, was to sort of get rid of that ticketing queue, right? Is to get to that place where the enforcement is automated. And so I think the important thing that really changes with sort of any policy as code engine is the workflow. And so the goal is really now what we see is the sort of decoupling, right? Where the compliance team is still responsible for defining their policy, but instead of doing it as sort of a Word document with a bunch of checklists, they turn it into a Sentinel policy, and that policy gets installed into whatever system is doing the enforcement itself. So in this case, as an example, Terraform Enterprise. And so now as an operator, I can write my Terraform that says, great, I'm going to deploy my service. I've only asked for 5 VMs, and I turned on HA in the database. So I submit that to be changed. The system can automatically sort of evaluate and say, yep, looks good, you're within the sandbox. Feel free to apply. And this way, there was no ticketing. There was no sort of like, please wait 2 weeks until we review. Now, if I had made a mistake and said, whoops, ask for 500 VMs and submit that to the system, it would right away flag it and say, nope, sorry, can't do it. Here's why, right? This is the policy you violated. And so now I get this sort of fast feedback loop as an operator. I can go back in, be like, oh, whoops, I only met 50, go and change my policy, resubmit it, now I'm allowed, and I'm off to the race, right? So it's really about decoupling the sort of definition of the policy that the compliance team is doing with the enforcement that can now be automated. And so I think, Mitchell, this might be a good time if you want to do sort of like make this a little more concrete for people.
Yes. Okay, so let me take the screen. Actually, Amanda, could you give me the screen, please? Cool, I got it. So let's see if I can get this to work. Okay, so I think, Armon, can you verify that the Terraform Enterprise is showing up?
Yep, looks good.
Cool. So what I've sort of set up here, let me zoom in a bit because my screen's a little big. What I've sort of set up here is a set of workspaces, which are Terraform configurations and runs that are in various states of policy. I've also set up their configuration. So I'm going to show each of these, but in the interest of time, I already ran them. So within Terraform Enterprise, there's you could set policies sort of at an organizational level. So I've set up 2 policies here. So the first one is restrict AWS region, and the second one is that a VPC and AWS must have tags. So let's look at the top one first. For restrict AWS region, this is a hard mandatory policy. So these are the enforcement levels that we talked about. Is a hard mandatory policy, must be passed. And in this case, what we're doing is verifying that sort of the region that is being used is only US East 1. There's a lot sort of going on here that includes a lot of debug information if something fails. Like I said, I'm using policies here that we've sort of have permission and pulled from real customers. And so this policy is just verifying that all your resources and any usage of AWS in any module within your configuration only touches, in this case, US East 1. You could imagine sort of easily changing this if you wanted to something like this, but I'm not going to do that right now. The other policy is that VPC must have tags. So this policy is soft mandatory, so it could be overridden. And this is just that all VPCs must have at least 1 tag. So the actual core of the check is right here. After the apply, there should be at least 1 tag. So greater than 0 tags. And the rest of this here is just, again, just some functions and stuff to get every VPC and every module throughout the configuration. And these are 2 policies. So to help sort of do this, I have a set of Terraform configurations that I have. And the way Terraform Enterprise works is that it hooks into a VCS. So when you create a new workspace, you sort of use your GitHub or Bitbucket or GitLab or anything else, and you connect to the source there. So your infrastructure as code, lives in your VCS. I've already configured these, like I said, to connect to this repository. So I have a few scenarios here. I have a passing scenario where I have a configuration that looks good. I have a scenario that I forgot to put tags on the VPC. I have a scenario that I have tags on the VPC, but the region is not valid. And I have one that just fails everything. So let's start with the passing one because it's the most straightforward. So in this case, I've configured the provider to US East 1. You could recall that one of the policies is that we must be using the US East 1 region. And I've also created a VPC that has tags on it. So this should pass all the policy. And if we go back to our workspaces and go to passing, we'll see we're in this policy checked state. So if I click on the run, which I started a while ago, we can see that the plan happened, which says it's going to create a VPC. And then beneath the plan as the next step in this timeline, we did the policy check. So if you don't have any Sentinel policies, this doesn't show up. But since I have Sentinel policies, we have a policy check, and we can see that they passed. If you click this, you can see more detailed logs. So you can see all those. That one had a lot of debug information. You could see some of it here to get information. But these are the policies, and if I wanted to, I can now apply it. But I never applied or made the infrastructure change here. But pretty straightforward on the passing side. The next one we'll look at is the soft mandatory one, which is, let's look at no tags. I think that was a soft mandatory one. So no tags, so policy override state is here. So if we go to the no tags one, it'll look very similar. The same plan executed, the plan should look the same. And now in the policy check, we have this orange policy soft failed. So in this case, there were policies, the hard ones passed, but the only ones that failed were soft mandatory. And again, you could view this information to figure out what failed. You could see that this policy was the one that failed, and it was soft mandatory. And you could also see the trace. So this is sort of that rule-based debugging we could give you, which is that the first sort of predicate we came into was the main rule on this line. That sort of nested into this predicate statement on line 15, column 3. And that ended up being false, which caused this rule to be false. And so you could see sort of the logic train that happened. But given that I'm an owner of this organization, so as an owner of this organization, I could actually choose to override it. I could type, ignoring the policy. So for some historical record, hit override and continue and actually have it make infrastructure. I don't particularly want to make infrastructure right now, so I won't, but you could do that easily. Looking at another one here is bad region. So in the case where we have tags, but we specified an incorrect region. So everything looks good except we're using the West Coast, which again is against our hard mandatory policy. If we look at that one, very similar again. In this case, we have a red X though, because the policy's hard failed. Again, the checks are going to look similar. I don't need to look into that. You can see a hard failed, and you can see no matter what, there's nothing I can do about this. I could leave a comment talking about, maybe I'm looking into it or something, but there's no way to apply this plan. This cannot be, this infrastructure cannot be changed. And you'll notice sort of like throughout all these, I'm really breezing over the sort of standard Terraform Enterprise features, but you can see sort of who initiated it, what commit initiated it. If I click that, then it would go to exactly that commit. If I were to say, if someone else were to write a comment here, the comment would be by that person. If someone were to override the other one, you would see who overwrote it. So you give this nice history of infrastructure change. And so then the last thing I want to look at is bad everything. Like everything is wrong with this configuration. You can see that there's no tags, and we're using the wrong region. And sort of surprisingly, not very interestingly, this also hard failed. So although there was a soft failure in here, if there's a hard failure, there's no recovery from that. So we sort of don't highlight that there's soft failures. We just note that it's immediately hard failed, and you can't go on from there. If I were to sort of go through, and I could probably sort of, let's say that this Sentinel policy, the region 1 is actually now advisory. We don't actually care if that passes. I could save that policy, go back to here, and let's find the bad region. So this previously hard failed. If someone's covering this, but if I queue a new plan here, this should only take maybe 20 seconds or so. But if I queue a new plan here, this should now pass. It should note that there were some advisory policies that failed, but it should otherwise pass. You can see the plan happened. Now it's doing the policy check. And yeah, you can see sort of policies failed, but advisory only. So we can immediately, as a non-owner, as the user who initiated this, I could immediately confirm and apply and make this infrastructure change. And that has sort of a slightly different visualization as well. But you can see how easy that was you can imagine somebody else coming in here and twiddling these policies. And that's pretty much it. So I'll hand it back to Armon.
Cool, thanks, Mitchell.
Waiting on Armon's screen.
Cool, I think it flipped over.
Yep.
Awesome. Thank you. So I think there were some questions about how Sentinel applies to the other tools as well. And so, I think this was the hope of showing it through Terraform Enterprise is to make it a little bit more concrete and take it away from being sort of an abstract concept. But in principle, the same idea kind of applies to any of these tools, because ultimately, really what we're trying to get at is some meta way of imposing kind of this sort of sandbox constraint on what can be done in any of them. So in that same spirit, Sentinel has been integrated across all of them, right? And so what you can do is slightly different in each of them, right? With Terraform, because it's sort of provisioning infrastructure, you're ultimately defining sort of the sandbox of what type of infrastructure can be provisioned, right? Slightly different as you move to something like Nomad, where not necessarily doing that. But the kind of policies you might have in something like Nomad might be, hey, you know what, we're generating and managing encryption keys and encrypting data at rest. You might have a policy that says, although Vault can do 128-bit encryption, you have an organizational standard that says it must be 256. So you could have a Sentinel policy that says, sorry, reject any encryption key that you try and create or any operation you try and perform that tries to use less than 256-bit. And again, that might be an advisory thing too. You might just say, as a warning, this might not be something you want to do. And then Nomad sort of operates at a bit of a different level, right? We're provisioning now sort of applications on a pre-existing cluster. So we're not booting infrastructure, it's assumed to be there, but there might still be constraints you want to impose, right? So a very common one we see is, what types of workloads Nomad should be allowed to run. So Nomad can run anything from, Docker or LXC or Rocket or, KVM if you want to run a full VM. And so you might have an organizational standard that says everything must be a Docker container, so that if someone submits something and says, hey, please provision a VM on the Nomad cluster, the system will just reject it and say, no, must be a container, right? The other thing you might want to do is impose sort of size limits, right? Developers tend to be notoriously bad at wanting to debug their memory leaks, so they might say, yeah, throw 32 gigs at my container and I don't have to deal with the problem. And so you might write a policy that sort of limits the amount of CPU and memory a particular job can request. And the last one is console. I think Mitchell mentioned it earlier, is if you're using the key value store as sort of a config store for your applications, you might have some sanity checking that's like, are the keys laid out in the right path? Are they formatted correctly? Is it the right sort of structure that the application is going to understand? Sort of more in vein with that sort of operational excellence. So kind of wrapping it up, I think our view in general is that policy as code builds upon the sort of as code movement, right? And that if you do it correctly, you get many of the same benefits of infrastructure as code, right? So you get the reuse and the abstraction and the sort of this higher level automation, which is great. But then you also get the sort of safety guardrail around infrastructure as code as well. So it provides this sort of sandbox that makes it so that you can kind of work around a little bit the paradox of automation, so that you can have kind of both the huge leverage, but also a little bit more control and sort of risk management around it as well. And so our sort of view, our approach on it is Sentinel, which is kind of this multifaceted framework that Mitchell laid out. And ultimately our view is, if infrastructure as code is going to be successful and sort of used in large scale organizations, you need things like policy as code to make it actually safe to do so. And so with that, I think we'll sort of end the presentation and switch over to questions. So let's see, Mitchell, do you want to maybe go ahead and tackle the first one?
Do you want me to read them, or is Amanda gonna?
Yeah,
I think they're already in there, huh? Let me open them.
Right.
Okay, yeah, I'll start tackling them. I see them here. Okay, so top question, which is really important actually. Can you import Sentinel policies from a Git repo? So currently, no, but that was planned from the beginning. So that work is planned, and there's even like, if you were to use Sentinel today in Terraform Enterprise, there's even a box that tells you sort of that's coming. So that's extremely important to be able to properly version these things. But for now, we're recommending that people put their policies into a Git repo, but then with the right permissions on the website, you're just sort of putting the policies directly there.
Yeah, and there is an API as well, but yeah, the Git ingress is coming soon.
The next one, policy applies globally. Can we have a policy for an environment instead of an org? Environments are now named workspaces, but yeah, you could, you can't currently, but that's coming really soon too. That's also on the short list of workspace specific policies. That'll sort of come along with, in a way, the Git stuff, because what we want to do is have all the Git policies come in as a library of policies and allow you to sort of choose which policies and which enforcement level for that workspace. And so that they're tied pretty closely in this case.
I think today the way people tend to do it is just filter on the workspace. So you could just have a rule that short circuits if it's not sort of applicable to that particular workspace.
Yeah, that's a good point. The workaround that we recommend today is you have access to workspace name in the policy. So kind of a hack, but it could work.
Yep.
I'm going to skip the versioning question because that's VCS related. A lot of these questions are actually based on tracking changes and history, and those are all, you'll get those from version control eventually.
Cool.
Let's see. Is the plan stage here run in a sandbox, not against a real API? So this is more of Terraform and unrelated to Sentinel, but it's important to understand is that the Terraform plan will hit the AWS API in a read-only mode to determine sort of the state of the world, but it doesn't actually make any changes to the infrastructure. So it requires a valid AWS key, credentials, and so on, but doesn't make any changes. So that's a sort of guarantee or feature that Terraform gives you. And so when you're doing the policy on the plan, it's on that. And one of the other benefits is that, say you make this plan and then you don't get to check the policy for 2 days and the state of the world changed. When you hit apply, like the plan looks good, policies look good, apply. If the state of the world has changed in a way that would affect the plan would be different, then Terraform will fail. It won't actually apply that anymore. And so you would have to re-queue a new plan.
Cool. Do you want me to tackle this next one?
Yep, go for it.
So there's a question about, so Azure has ARM policies which can accomplish some of these sort of similar examples, and then sort of more generally, cloud service providers typically have their own systems for doing policy enforcement. So there's sort of a similar concept in IAM and a similar concept in GCP. And so I guess the question is really A, are these things compatible with each other? Are they orthogonal? And B, sort of what's the trade-offs between them? So I think one way to think about them is they are orthogonal in the sense that you can use both of them at the same time. So you can layer an ARM policy or an IAM policy with a Sentinel policy. They'll both just apply. But I think the big difference is Terraform lets you have a much more sort of context-rich view of it, right? And it goes back to that same sort of ACL view versus sort of a policy view. It's very hard in many of these sort of IAM type constructs or ARM policy constructs to pull in the relevant context, right? Of, hey, I want to understand, is this a staging environment, or, this rule only applies in the presence of some other resource, and sort of have this more holistic view of it. And that was one of the goals of Sentinel, is that you can kind of pull in as much context as you need and sort of make these much more contextual decisions, right? The other aspect of it is it's not really tied to any particular cloud. So, we saw a few different examples of Sentinel policies. One was, GKE stuff, cluster standard, and then Mitchell did one on VPC tags in AWS. And so I think one of the advantages is it doesn't end up having to be a different sort of policy, a different language, a different specification across all of these things. It's a much more uniform way of applying policy across sort of any type of resource.
So there's some questions. I'm going to try to focus on the Terraform and Sentinel related questions.
Cool.
Okay, can you use Terraform to continuously monitor the infrastructure against the policies? This is a good question too, and similar to the other answers I've been giving, that's coming as well. So I could explain the way that'll work too. Basically, we'll have policies that you'll be able to run against the state of Terraform. Obviously, there's no plan happening if you're just watching the state of your infrastructure. So policies that would be running against the state, and what we'll do is periodically run Terraform refresh, which updates Terraform's view of the state of the world, and then run policies against that. So the idea there, the use case there is, you probably already know, but for others, is to allow policies to detect drift or your infrastructure coming out of compliance without Terraform Enterprise. So the idea is that if you have the right policies, Terraform Enterprise will never let you get out of compliance initially. But say you're introducing a new policy, or someone goes into the sort of cloud dashboard and clicks around and changes things outside of Terraform Enterprise, then we'll still be able to detect those as well.
Cool. Mitchell, I know we're running short on time. Do you want to maybe just take 2 last questions?
Okay, I'm gonna sort of pick randomly here. Let's see. Okay, does Sentinel in a way change the way we write Terraform? No. So importantly, it should not, except that you should write compliant, I guess, Terraform, but the syntax doesn't change. There's no new syntax on top of what exists. The idea is that your engineers, your operators should continue to write Terraform as they know Terraform, and the policies will fail if they do something wrong, and they could just sort of change it.
Cool. Well, maybe do you want to do, it looks like there's a few common questions about kind of like when and where Sentinel runs.
Sure. Is there a number you can point me to, and then I'll, okay, I see it. So there's various places we could run Terraform. And so I already hinted at 2, right? We already run today between the plan and apply. We want to run in the future just after refreshes periodically. And there is a difference there in what you could detect and what you're enforcing. And the way we like to think about it is like, are you in the enforcement path or are you out of it? And if you're in the enforcement path, you are, another way we've presented this is you're actively denying non-compliant behavior. You are preventing behavior that would put you out of compliance from ever happening. If you're out of the enforcement path, then you are passive and you are detecting non-compliant behavior that has already happened. Sentinel is capable of doing both. Currently in Terraform Enterprise, it's only in the active sense. We also want to enable the passive sense. And yeah, I think those are the 2 places Terraform Enterprise would see it. And that sort of varies by product as well. But there is a cost association in terms of time and resources to know what that, or even like costs of being out of compliance in the first place. Yeah.
Awesome. Cool. Well, thank you so much, Mitchell. Thanks for joining me. This has been awesome. We'll hand it back to Amanda.
Okay,
Thank
thank you, Mitchell and Armon. I hope everyone enjoyed today's webinar and was able to learn more about Sentinel with Terraform Enterprise. Thank you to everyone who joined, and a big thank you to Mitchell and Armon for their time today. I also want to mention that HashiCorp is hiring, so if you like what you heard today, please take a look at our jobs page at hashicorp.com/jobs if you think there might be a fit for you. And finally, as I mentioned at the beginning, this webinar was recorded, and we will make the recording available on our website after processing. I'll send an email out to everyone who registered with the recording link. You can also keep your eyes out on Twitter, where I'll post the recording usually a little later today. Have a great day. Goodbye, everyone.
Thanks.